Hi everyone, I'll be walking you through this practical. So these are all the skills that you're supposed to be covering in this practical. You can go through it and these are all relevant to your IA. Here you have the list of equipment that you have used and the list of chemicals. You're going to include the safety involved when you're using each of these chemicals. So you're going to Google for example, for NaOH, MSDS of NaOH. MSDS stands for Material Safety Data Sheet. So it gives you an idea of what are the precautions that you have to take when you're handling these chemicals. And normally, when you're including the safety, whenever possible, whenever you know the concentration, the safety should be related to the concentration. For example, safety involved when using 0.1 molar NaOH is not going to be the same as handling 2 molar NaOH. So all safety has to be in relation to the concentration that you're using. For HCl, we don't know the concentration, so you have to mention general safety when using HCl, as well as methyl orange, which is our indicator. And you include the safety as well as the environmental consideration, which involves what are the precautions you're going to take to discard it properly. So there are some chemicals that should not be discarded in the sink. They should be discarded in special bottles. So include that as well. And when you're writing your safety, you need to include in-text citations, and all of these will be mentioned in your bibliography. So this is my method, and this is my raw data where I'm going to record. This is a table where I will record my raw data. And you can see this is the uncertainty of the initial burette reading, uncertainty of the final burette reading. And this is the uncertainty of the difference between these two. And if you remember, uncertainty, when you have two values, whether the two values are being added or subtracted, uncertainty will always add. So this one has uncertainty 0.05 and this one has uncertainty 0.05. So they add up and they give you the uncertainty of 0.10. This is what we have here. And if you look at this, this is to 2dp. So all my values here have to be to 2dp. All my values here have to be to 2dp. And because this is 2dp and this is 2dp, this should also be 2dp. Right? I'm going to be using mock values for the calculation just to show you how to do it. So these are my mock values, and it says here you have to titrate until you get consistent results. So what are consistent results? Consistent results is when your titer values agree within 0.1 centimeter cube. You can see here there is only a difference of 0.1. These are consistent readings. Once I have consistent data, I can now continue processing. Average volume will be an average of these two values like this. And now I'm going to show my stepwise calculations. And one thing, note that the average value is also to 2 decimal place. So throughout my table, the decimal places are consistent. Now, let's see calculation. For my calculation, I want to show all the steps as clearly as possible. So I'm going to start with my average, actually, like this. And when you're using average, let's say you have recorded, you have done the titration 7 times. When you're doing your average, you only use consistent results to do your average. So you're not going to use all the 7 results. You will use only values that agree to 0.1 centimeter cube. So this is important. Now this volume of HCl, we have to know how many moles of HCl is present in this to be able to calculate the concentration of HCl. So now we're going to do the calculations. Because I'm going to be using this equation, I'm including it in my calculations. Now, to know the number of moles of HCl, I need to know the number of moles of NaOH, because if you see here, I have the concentration of NaOH, I have the volume of NaOH. So from this, I can find the number of moles of NaOH. And using the mole ratio, I can find the number of moles of HCl. So I include the formula, I include the values that I fit in the formula. Remember, volume is in centimeter cube. I need to convert to dm cube, and then I write my answer. If you want to write your answer in standard form, you can, or you can put it in decimal place. So this is number of moles of NaOH. Use your symbols well. Small n is for number of moles, capital N is for number of particles. So I'm using my formula well, I'm using my symbols well, and I'm using my units properly as well. Once I know the number of moles of NaOH, I will use the mole ratio and find the number of moles of HCl. Now I have the number of moles of HCl. So in this volume of HCl, there was this number of moles. So I have number of moles and I have volume. I can find concentration. So I have the number of moles here. I have the volume here in dm cube. This is in centimeter cube. I convert and I calculate. So now I have my concentration. Normally, this is 2SF. So I would give my answer to 2SF. But I'm not going to judge the SF right now. To know how much SF or DP I need to report my value, I will first do my uncertainty calculation. So I will keep it as it is for now, and I will do my uncertainty calculations. Now, when you do uncertainty calculations, you have to know that percentage uncertainties always add up. Now, what is percentage uncertainty? Percentage uncertainty is the value of the uncertainty in the equipment divided by the volume or the amount measured times 100. This is how you find percentage uncertainty. And for each equipment that you used for measurement, you're going to have a percentage uncertainty. So, if you look at the list of equipment, burette you used for measurement, pipette you used for measurement, and that's it. Everything else was not used for measurement, which means that I'm going to have uncertainties, percentage uncertainty of burette and percentage uncertainty of pipette only. So I'm going to write percentage uncertainty burette. So if you look at the burette, these are the values that we measured. But I'm going to find the percentage uncertainty in the average value. Alright, so then uncertainty of the burette is what? Is this. Because this is the error in that equipment after we have done final minus initial. So this is the uncertainty divided by the measured value times 100. So this is 1% uncertainty. Then I used a pipette. So I'm going to find percentage uncertainty in the pipette. For the pipette, you will have to look it up in the equipment itself. So be careful. Every pipette in the lab has different uncertainty depending on the grade. There's grade A, grade B, grade C. So depending on the grade that you use, it will have different uncertainty. So I am assuming that it has uncertainty 0.3. That's what I am assuming. Right? So 0.3 divided by how much we measured? We measured 25 ml. And this is going to be this. This is going to be 0.3. You have to look at the equipment times 100. So I have the uncertainty of the two equipment. Then I'm going to find total percentage uncertainty, which is going to be a sum of these two. So 1.64%, which means that there is an error of 1.64% in my concentration of HCl that I found. Which means now that I'm going to find the absolute uncertainty, which means what is the value of uncertainty? What is the value of error in my calculated concentration? So absolute uncertainty is percentage uncertainty divided by 100 times the value, the calculated value normally. So this is going to be 1.64 divided by 100 times the value of the concentration that I got. Now, this is the important part here. This is very important. This absolute uncertainty should always be to 1SF. So I'm going to rewrite this 0.003. This should always be to 1SF. Now I'm going to look at this. This is to 3dP. Because this is to 3dP, my concentration should be reported to 3dP. So then I can write concentration of HCl is 0.166 plus minus 0.003 mole per dm cube. That's how I report my concentration. So just to recap, the absolute uncertainty must always be to 1SF, always, and the number of dP of the absolute uncertainty will determine how many dP your value should be reported to. So this is the correct calculation, and this is the correct this is the correct concentration of HCl reported properly with uncertainty and with the unit. Now, what does this value mean? What does the percentage uncertainty mean? It means that my value of concentration of HCl is off by 1.64%. It could be higher by this amount or it could be lower by this amount.